Okay, phase shift. Phase shift is this C. So let's just sketch y equals 3 sine pi on 2x plus 7. Let's do that to start with. There's no C there, so this is easy. Centre of motion at 7. Amplitude is 3, so I've got to go to 10 and then down to 4. There we go. We need to put in t equals 2 pi on b. b is pi on 2, so that's 4. So that's 4. That's 2, 3, 1, 0, blast off. Okay. So that was easy. X minus 1. So here everything is the same. A is 3, D is 7, B is still pi on 2, so my time period's the same, but I've got this C here. All that means is, instead of starting here, I'm going to start 1 that way. So I'm going to start here and draw my sine graph. My time period is still 4, so if I start at 1 here, that means by the time I get to there, that must be 5. Halfway between 1 and 5 is 3. You can see how it's all the same. I'm just starting 1 over, and clearly I can keep doing my backwards one there. At some point you might have to 5 pi x plus pi on 2 minus 3. If it's not in the right form, you're going to have to get it in the right form by factorising stuff out. So you can't have a coefficient in front of that x. So it's got to be x. I've got to factorise the 5 pi out of that. So there's my 5 pi, but I've got to factorise 5 pi out of that. So that would be plus 1/10. That's a nasty phase shift, but anyway, it is what it is. Okay, so that sketching one, what if I give you one and go, hey, there's a graph, sketch it for me. What's the function? So you can see here that it doesn't start either in the centre of motion or the top or the bottom. It's over here, so we know there's a phase shift. So we're completely excited about that, but that doesn't phase us at all. We can see that. Let's just enlarge that. There's our bottom line, there's our top line. So we can see here that maximum's 10, minimum's 4. Where's halfway between 10 and 4? 7. So 7 is our centre of motion. Y equals, there's our D, plus 7. We're going from 7 up to 10 and down to 4. So our amplitude is 3. So it's 3 sine, okay. Let's look at our time period. So we can see here's a top and here's a bottom. It's taken from 1.5 to 3.5. So that distance is a distance of 2. If that's a time, that might be 2 seconds, minutes, hours, whatever. It's just x, 2. Okay, that's half a cycle. So a full cycle would go all the way down, so that means our time period must be 4. I don't mean to keep using 4 all the time. It is just what it is. Just random. Let's get rid of those things there. Okay, time period is 4. So let's go B equals 2 pi on T. T is 4. There we go. B is pi on 2 x. I guess I can leave that there. Okay. So, we've got 2 options here. We can look for the phase shift. Let's just go, because we've selected a sine graph, we're saying that a sine graph usually starts there. We can see that it started there instead, and that distance is a distance of a half. So in this particular case, and it's moved to the right, so it's x minus a half. C is just the phase shift. C is negative a half. Now, if for some reason you can't see that, if it's not clear on the diagram, you can find C another way. You can find C, so let's just go, you've got it's important that you choose we're going to find C by subbing in a point. It's important that you choose either a maximum, because that will be easier to spot, or a minimum. Guarantee if you put the maximum in of 1.5, 10, that's a point that lies on the line, therefore it must satisfy the equation. If you make x, so here we didn't actually know what C is, I'm going to make x 1.5. So x is, was it 1.5? Oh my gosh. Yep, 1.5. 1.5 plus C. And y was 10. I won't do it for you. You can work that out. You're just solving for C. Rearranging and solving for C, and that will get you the correct C. So it's a fail-safe way if you're not quite sure about what that phase shift is from the graph. But you must put in either a maximum or a minimum. You cannot put this point or any other point. It has to be a maximum or a minimum for it to work. Okay, good luck. Have some fun.